Hello, let's solve practice set 1.3. Question first. In figure, angle ABC equals 75 degree, angle ADC equals 75 degrees. State which two triangles are similar and by which test. Also write the similarity of these two triangles by a proper one-to-one correspondence. Okay, question first, solution. If you observe figure carefully, here are two triangles, triangle ABC and triangle EDC. Here you may note angle B having measure 75 degrees congruent with angle D whose measure is 75 degree. Means B correspond to D, and these two triangles have one vertex in common, that is vertex C. Means C correspond to C. Therefore, selected correspondence will be ABC 1 has to correspondence EDC. Okay, let's mention here. Here in a triangle ABC and a triangle EDC, angle ABC congruent angle EDC. Since each of measure 75 degree, again angle ACB is congruent with angle ACB is congruent with angle ECD, angle ECD. Since common angle, therefore as two angles of one triangle are congruent with two corresponding angles of other triangle, these triangles are similar by AA test. Let's mention here, therefore triangle ABC similar triangle EDC by AA test of similarity. And the correspondence is ABC 1:1 correspondence EDC, because A correspond to E, B correspond to D, and C correspond to C. Question second. Are the triangles in figure similar? If yes, by which test? Let's observe triangle PQR and triangle LMN. Here you may note PQ is 6 while LM is 3, QR is 8, MN is 4, PR equals 10 and LN equals 5. Means 3 2s are 6, 4 2s are 8, 5 2s are 10. Means their corresponding sides are in proportion. Let's mention. Here in triangle PQR and triangle LMN, PQ upon LM equals 6 upon 3, 3 1s are 3, 3 2s are 6, that equals 2 upon 1. Equation first, QR upon MN equals 8 upon 4. 4 1s are 4, 4 2s are 8. That's why ratio will be 2:1. Equation second. Similarly, let's find PR upon LN. PR is 10, LN is 5. 5 1s are 5, 5 2s are 10. The ratio is 2:1. Equation third. Therefore, from 1, 2 and 3, all the ratios are same. Means PQ upon LM equals QR upon MN equals PR upon LN. As three sides of one triangle are in proportion with three corresponding sides of other triangle. Therefore, triangles are similar by yes, yes, yes test. Let's mention here. Therefore, triangle PQR similar triangle LMN by yes, yes, yes test of similarity. Okay. Question third. As shown in figure, two poles of height 8 meter and 4 meter are perpendicular to the ground. If the length of shadow of smaller pole due to sunlight is 6 meter, then how long will be the shadow of the bigger pole at the same time? Okay. Now let's observe. AC is bigger pole, PR is smaller pole. PR is a pole, QR is its shadow. Similarly, AC is a pole, BC is its shadow. Okay. Now we know that poles are perpendicular to the ground. Okay. If we consider there is a sun, and we know that as sun is very far from earth, rays coming from sun are parallel to each other. Due to that, ray AB will be parallel to ray PQ, and as there is a ground which is horizontal, hence we may note angle PQR will be congruent with angle ABC because shadows are cast at the same time. Let's mention here. Okay. Here PR and AC are poles and QR and BC are their shadows respectively. Okay, as shadows are cast at same time, therefore directly we may mention, therefore triangle PQR is similar with triangle ABC. Okay, P correspond to A, Q correspond to B, and R correspond to C. Okay, and we know that if two triangles are similar, then their corresponding sides are in proportion. We are interested with PR corresponding to AC and QR corresponding to BC. Let's mention here. Therefore, PR upon AC equals QR upon BC, since corresponding sides of similar triangle. Okay, and therefore let's put known values. PR is 4, AC is 8, QR is 6, and BC let's consider as X, and therefore 4 into X equals 6 into 8. Therefore, X equals 6 into 8 upon 4. 4 ones are 4, 4 twos are 8. And therefore, X equals 12. Therefore, that is X is the length of BC. That is BC equals 12 meter. That is the length of shadow of bigger pole is 12 meter. Question fourth. In triangle ABC, AP perpendicular BC, BQ perpendicular AC, B dash, P dash, C, A dash, Q dash, C. Then prove that triangle CPA similar triangle CQB. If AP equals 7, BQ equals 8 and BC equals 12. BC equals 12. Then find AC. Then find AC. Okay. Now, if you observe triangle CPA and triangle CQB, you may note they have angle C in common. Angle CPA have measure 90 degree, angle CQB have measure 90 degree. Okay, means two angles of one triangle are congruent with two corresponding angles of other triangle. Therefore, triangles are similar by AA test. Let's mention in a proof. Question 4, solution proof. In a triangle CPA and triangle CQB, angle C congruent angle C, since common angle, then angle CPA congruent angle CQB, since each 90 degree. Therefore, triangle CPA similar triangle CQB by AA test of similarity. And we know that if two triangles are similar, then their corresponding sides are in proportion. Therefore, CP upon CQ equals PA upon QB equals CA upon CB, since corresponding sides of similar triangle. And therefore, now let's put known values. CP, we don't know what is the length of CP. CQ, we don't know length of CQ. Let's keep CP and CQ as it is. But PA means AP, which is 7. QB means BQ, which is 8. CA, we don't know about that CA, but CB is a BC, which is 12. Okay, first ratio equals second ratio equals third ratio. As we don't know about numerator or denominator of first ratio, let's omit first ratio. Let's show second ratio equals third ratio. Therefore, let's mention here 7 upon 8 must be equals CA upon 12. And therefore, 7 into 12 equals CA into 8. Okay, and therefore CA equals 7 into 12 upon 8. 4 2s are 8, 4 3s are 12, 7 3s are 21 upon 2, 2 1s are 2, 2 1s are 2, 2 0 0, decimal 2 5s are 10. Therefore, CA equals 10.5. That is, AC equals 10.5. Question 5th. In trapezium PQRS side PQ parallel side SR, AR equals 5 AP. AR equals 5 times AP. Let's mention AR as 5 AP. Okay. And this PA means AP is 1 times AP. Length of AP is 1 times length of AP. AS equals 5 AQ. AS equals 5 AQ. Okay, AS equals 5 AQ and AQ is AQ. Then prove that SR equals 5 PQ. SR equals 5 PQ. Okay, now if you observe a diagram carefully, you may note here is a pair of triangles, triangle APQ and a triangle ARS. I have selected this correspondence because angle A of triangle APQ is vertically opposite with angle A of triangle ARS, means this angle. Okay, and vertically opposite angles are congruent. And again, as PQ parallel to SR and PR is there, transversal, we may show angle APQ congruent angle ARS. Okay, because it is a pair of corresponding alternate angles, and we know that as two angles of one triangle are congruent with two corresponding angles of other triangle, therefore triangles are similar by AA test. Let's mention here in a proof, question 5th, solution proof. From figure, let's mention here in a triangle APQ and a triangle ARS, because A correspond to A, P correspond to R and Q correspond to S. Okay, angle PAQ is congruent with angle RAS, since vertically opposite angles. Then angle APQ congruent angle ARS, since alternate angles, and we know that alternate angles are not always congruent. Okay, they are congruent if and only if the lines are parallel and they have a transversal. That's why once again reason for a reason, since PQ is parallel to SR and PR is a transversal. Therefore, triangle APQ is similar with triangle ARS by AA test of similarity. Okay, and if two triangles are similar, then their corresponding sides are in proportion, CS, ST. Let's mention which are those. AP upon AR equals PQ upon RS equals AQ upon AS. And therefore, let's put values. AP is AP. Okay. And then AR is 5 times of AP, since it is given. Similarly, let's write PQ. We don't know about PQ. We don't know about RS. We are interested to prove RS equals 5 times PQ. Okay. AQ is AQ and AS is 5 times AQ. Okay. Then AP1s are AP, AP1s are AP, AQ1s are AQ, AQ1s are AQ. Since he provided AR is 5 times AP and AS is 5 times AQ, since it is given, and therefore we can write PQ upon RS equals 1 upon 5, and therefore RS equals 5 times PQ. RS equals 5 times PQ. That is SR equals 5 times PQ. Hence the proof.